what is the characteristic equation? Okay, the characteristic, what is the meaning of characteristic equation in the sense? Okay, it will tell the behavior of, it will tell the behavior of flip-flop in algebraic equation format. That is called as a characteristic equation. What is the meaning of characteristic table? The characteristic. What is the meaning of characteristic table? So characteristic table is, it tells the behavior of the circuit. It will tell the behavior of the circuit. It will tell the behavior of flip-flop. Okay. So what are the parameters are available in the characteristic table? Suppose this is a JK flip-flop. JK. What is the previous state output? The Qn plus 1 is called as a current state output, or otherwise called as a next state output. Okay. After that we have seen, okay, what is the excitation table? Okay, we have seen that what is the excitation table? What is the excitation table? The excitation table. The excitation table is, okay, for example, this is a previous state output, and this is the current or next stage output. Means, what is the input combination? Okay, what is the input combination for J and K? That can be represented in the tabular format. The table we call it as excitation table. And then last we have seen state diagram. Okay, so we have seen the state diagram. Okay, okay. So do you have any queries? What we have seen in the last class? Do you have any queries? Say yes or no. I am asking for you. Hello.
No, sir.
Okay, next one is, next flip flop is called as a D flip flop. The next one is called as a D flip flop. Okay, so this is a circuit diagram for or specification for D flip flop. Okay, J, K. So what is the another input in the sense? The inverter of D. This is the input for K. And then this is a Q, and then this is a Q bar. Okay. Okay, what do you understand from this? Suppose, okay, my input is D. Suppose I am a user, I am going to provide input as 0. What happens, sir? J value equal to 0 and then K value equal to 1 because the inverter is there. Okay, this is called as an inverter. Okay, this is called as an inverter. Okay, this is called as an inverter. Okay. Suppose I provide input is 1. What is the value of J and K? They get J value equal to 1, K value equal to 0. Okay, based on that, what happened? I'm going to write the truth table or function table. Function table or truth table. Okay, here I'm going to write it. Function table or truth table. Function table or truth table. Okay, so I'm taking input D. Okay, and then I'm going to take the previous stage output because this is a sequential circuit. How the sequential circuit is working on? It is a current input plus the current input plus previous stage output. The current input plus the previous stage output. So based on that, what happened? It prepares a next stage output. That's why I'm taking Q1. This is called as a previous stage output. Stage output. And this one is called as a current input. This one is called as a current input. Okay. Okay. Suppose I am going to provide input is 0. I'm going to provide input is 0. Okay, this is nothing but what is the next state or current state output. Okay, okay. So I'm a user. What I'm going to do, I'm going to provide input as a 0. Uh, okay. Um, okay, the previous stage output is 0. So if d value equal to 0 in the sense, what happens? The d value equal to 0 in the sense, j value equal to 0 and k value equal to 1. Okay. Okay, in order to fill this table, what happened? You want to refer JK flip-flop truth table. Okay, what is the truth table for JK flip-flop? Okay, what is it? The truth table for if the both are 0 in the sense, what happened? So it will retain the previous stage, 0 1 in the sense 0, 1 0 in the sense 1, and then 1 1 in the sense it's a complement. Okay, this is a truth table for JK. Okay, this is a truth table for JK. So based on that, what happened? You should fill up that D flip-flop. Okay, what is it here? What is the combination? J equal to 0 and K equal to 1. J equal to 0, K equal to 1. What happens, sir? The output equal to 0. Okay, so I am taking input is 0, but the previous stage output is 1. What happens, sir? So D equal to 0, G equal to 0, and K equal to 1. Okay, what happens, sir? Okay, the 0. Okay. What is the next step? The user taking the input is 1, but the previous stage output is 0. What happens, sir? So 1 in the sense what happens? Okay. J equal to 1, K equal to 0. Okay. J equal to 1, K equal to 0. So what is the output? 1. Okay. So user providing input is 1. The user going to provide input is 1. The previous stage output also 1. Okay. So what is the output? If user d value equal to 1 in the sense, j value equal to 1, the k value equal to 0. Okay, because here I am going to provide 1, here what happened? The complement. That's why j value equal to 1 and k value equal to 0. What happens, sir? 1 0. 1 0 in the sense 1. Okay, this is a truth table for D flip flop. Okay, do you have any queries? Sorry, this is
No,
a
sir.
okay. This is not truth table. This is a characteristics table for JK flip flop. This is nothing but characteristic table for characteristic table. Okay, this is a characteristics table for D flip flop. Okay. So now what we are going to do? So once we successfully find out the characteristics table. So what is the next thing? The next thing is called as a characteristic equation. Okay. Next one is characteristic equation. Okay. How do you do that? You want to minimize this function. Am I correct? If you do that, what happens? You will get one Boolean algebra. That Boolean algebra we call it as a characteristic equation. Okay, how do you do that? So this is a four input combinations are available. For that, what happens? You take two variable column. Okay, D and then QL. Okay, 0 1 0 1. Okay, and then fill up the table. What are the places output value equal to 1? Okay, what are the places output value equal to 1? 1 0. Okay, 1 0 1 0 here, 1 1 1 1 here. You are unable to map it. So what happened? You take each minterm and then represent it as a equation format. So what is the value? Okay, d bar qn plus here what happens, sir? D and then qn. Okay, this is a characteristic equation for D flip flop. Okay, it's okay for you. It's okay for you. Hello. Sir, I am asking for you, sir, whether you are understood or not. That's why I am asking you. Okay. That equation we
Sir,
can written as like that. Okay, you can minimize. Here Qn is common between two terms. Okay, and take it out. Qn plus for 1 0 1 1 1 0 1 0 1 0 இங்க sir, I wrongly saw the tournament, but even though you are not identify the error. Sir, here 1 0 1 0 1 0 1 1 in the sense here. Okay, now what happened? We can minimize it. How do you do that? D and then Qn. Okay, what happens, sir? This is a constant. The rest of the values are changing 0 1. What happens, sir? These are cancelled. Only remaining value is the remaining value is 1. What is the characteristic equation for D flip flop is only D. Okay, so what do you understand from this? Suppose whatever information you are going to give that flip flop, same thing is providing as an output. For example, I am giving the input as a 0 in the sense. I am going to provide input as a 0 in the sense. What happened? The output it is nothing but 0. Suppose the user providing input is 1 in the sense. What happened? It provide output as 1. Okay, that is a characteristics for. This is a characteristic equation for D flip flop. Okay. Okay. Next I'm going to talk about how to write excitation table for how to draw excitation table for uh, D flip flop. Okay. How do you draw the excitation table? Excitation table. Okay. How do you draw the excitation table? Okay. How do you draw that? Okay. You had a Q and there is nothing but previous stage output and then next stage or current stage output. So, for example, okay, but if it is there, what is the input value for the? For example, I'm taking the previous stage output equal to 0 and the current stage or next stage output equal to 0 in the sense what is the combination for D? What is the input combination for D? 0. Similarly, I'm taking uh, previous stage output is 1. The current stage output is 1. What is the input combination for D? 1. Similarly, the previous stage output is 1. The current stage output is 0. What is the input combination for D? 0. Similarly, previous stage output equal to 1. The current stage output equal to 1. What is the input combination for D? 1. Okay, this is the excitation table. Okay, it's okay for you? It is okay for you or not? Okay.
Yes,
So
sir.
next, based on that, what happened? I'm going to draw state diagram. Okay, based on that, what happened? I'm going to draw the state diagram. Okay, already is it. If we consider any flip flop, it's going to generate the two output. Okay, one is called as a 0, another one is called as a 1. Okay, if you consider any flip flop, okay, it try to generate two output, either 0 or 1. For example, how we are going to draw the state diagram? For example, I am there. Qn is nothing but previous stage. I am there in the 0, and there in the 0. Okay. Whenever my input value equal to 0, what is the next stage? Okay. So what is the next stage? 0. It's 0. I'm there in the state 1. I'm there in the state 1. I accept the input 0. I accept input 0. What is the next state? The next state is 0. Okay. Next state is a 0. Sorry, next state is a 0. My input also 0. Okay, I am there in the state 1. I am there in the state 1. I am accept the input value is 0. Whenever I am going to accept the input value is 0, what happened? The state change from 1 to 0. Okay. Next, I am there in the 0 state. And then in this 0 state, I am accept the input 1. I am accept input 1. So whenever I am going to accept the input 1, what happened? The state change from 0 to 1. 0 to 1. Okay. So I am there in the 1 state. I am there in the 1 state. I am accept the input value 1. I am accept input value 1. So whenever I am going to accept the input value 1, what happened? Okay. What happened? So what happened in the sense? I'm in the same state. I'm in the same state. So that is called as a state diagram. So do you have any queries? Do you have any queries?
No, sir.
So now I'm going to summarize it. As of now, what we have seen that, uh, as of now, what we have seen that, what happened, I'm going to summarize it. Okay. So as of now, we have seen different types of flip-flop. Okay. What is called as a SR flip-flop. One is called as SR flip-flop. So what is the function table? I'm going to list down the function table for all the flip-flops. Function table. Let's see one by one. First, I'm going to begin with SR, SR, and then what is the next stage output? If the input combination is there, what is the next state output? So these are the input combinations of the 0, 1, 1, 0. Okay, 1, 1. Anyone tell the answer? What is the function table for SR flip flop? Anyone tell that? Anyone tell that? What is the function table for SR flip flop? Anyone tell that? Hello? Anyone tell that? What is the function table for SR flip flop? Deva? Okay. If the input combination is a 0, 0 in the sense, what happens? It will retain the previous state. Okay. Suppose my input combination is a 0, 1 in the sense, what happens? The output value equal to 0. 1, 0 in the sense 1. This is called as a forbidden state. Okay. Not defined. So next I'm taking for JK flip flop. Okay. J, K, Q, suffix 1. Okay. The JK flip flop is similar to SR flip flop. But one variation is there. What is the variation in the sense? If suppose the user given input is 1 1 in the sense, for that they provide a definition. So there is a only differ. Okay, 0 0 0 1 1 0 1 1. So what happens, sir? Qn 0 1. Okay, what happens? This is nothing but Q complement. Okay. The next flip flop is called as a T flip flop. T flip flop. So what is a T flip flop? What is the behavior of the function table for T flip flop? T one next stage. Suppose our user providing input is 0. What happens? What it does in the sense? Okay, it will retain the previous stage. Suppose the user providing input is 1 in the sense, what happened? Okay, it produces output the complement of previous stage. Okay, the next last flip flop is D flip flop. As of now, we have seen. Okay, what is it? Anyone tell that? Just now we have seen. Anyone tell that? What is the truth table for D flip flop? What is the truth table for D flip flop? Suppose I am going to provide input is 0. What happened? Same thing is produced as output. Q. Suppose I am going to provide input is 1. Same thing is produced as output. Okay. So already Q1 is 0, complement in the sense 1. Okay. So that is a function table for all the flip-flop. So do you have any queries?
No, sir.
Next one is the conversion of flip-flop. conversion of flip-flop. Okay. So in order to perform conversion, okay, you should follow certain guidelines. They provide two guidelines. One is the characteristic table of recurred flip-flop. And second one is you needed excitation table for table of okay excitation table of existing flip-flop. Existing flip-flop. Okay. I will take one example and then I will explain you. Um, okay. Before proceeding there, I will list out the excitation table of all the flip-flop. Okay. If you know that, then only what happened, successfully you can do that. So first I'm going to list out the excitation table of all the flip-flop. Anyone tell that what is the excitation table? Anyone tell that what is the excitation table? No one knows that. What is the excitation table? The excitation table in the sense they provide a previous stage output and then they provide the next stage output. Okay, if it is there, what is the input combination of SR or JK or D or T flip flop? Okay, so I'm taking like that output combination 1 1. Okay, this is excitation table of SR 1001 X 0. Okay, this is excitation table for JK 1x x1. The x is called as a don't care condition. Okay, 0 0 1 1 0 1 1. Okay, this is the excitation table for all the flip. This is for JK, this is for SR, this is for D, last one for T flip flop. Okay. Okay. Now what happened? Now I am going to perform conversion. Okay. For example, I had a one flip flop. That flip flop is called as a SR flip flop. I want to convert it into JK flip flop. JK flip flop. Okay, how do you do that? Okay, if it is given, what happened? Okay, you should know two parameters. One is nothing but the characteristics table of a recurred flip flop. So here, which one is a recurred? Which one is the existing one? This one is called as a recurred flip flop. This one is called as a recurred flip flop. This one is called as the existing one. The existing one you converted as the recurred format. Okay. This is the existing one. This is a recurred one. So what you are going to do? So what parameters are needed for recurred one? The recurred one is needed for characteristics type. Here, okay, you had JK flip flop. Okay, JK. JK. Okay. How the characteristics table appear? What are the parameters are involved in the characteristics table? Input combination and previous stage output. Okay. 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 You can take it any order. Okay. 0 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1 0 0 1 1 1 1. Okay, what is the next stage output? Okay, if the input combination is 0, 0 in the sense, what happen? It will return the previous stage output. Okay, it will return the previous stage output. Okay. If 1, 0 in the sense, what happens? So it should appear in the reset state. Okay, this is a 1, this is a 1. Okay, what about this one? Okay, if the input combination is 1, 1 in the sense, what happens? Okay, it's a complement of the previous stage output. The previous stage output is 0, complement is 1, 1, 0. Okay, this is for excitation table. So next thing is nothing but you needed sorry, this is nothing but the characteristic table for record one is 0, 0. Okay. The next one is you needed a excitation table for existing S and R. Okay, what is the excitation table for S and R? Already we have seen that. Okay, so I hope that all of you know that. That's why I simply what happened. I'm going to fill up the table 1, 0. It is sorry, sorry. Okay, so what is the input combination? Here 0 and 0. If the input combination is 0, 0 in the sense, what is the excitation table? What is the value of S and R? 0, 0 in the sense 0 x. Okay, next. My input combination is 1, 1, 1 in the sense, what is the value of X and R? Sorry, S and R, don't care condition, and 0. So my input is 0, 0 in the sense, what happened? 0 X, 1, 0, 1, 0, 1. Sorry, sorry. Wrongly I filled up the table. Sorry, sorry. Okay, 0, 0. Okay, 0, 0, 0 means what is the value? 0 X, 1, 1 in the sense. So 1, 1 means X 0. Again 0, 0, 0, 0 in the sense 0 x 1, 0, 1, 0 in the sense 0, 1, 0, 1, 0, 1, 1, 0, 1, 1, 1, 1 in the sense x 0, 0, 1, 0, 1 in the sense 1, 0, okay, 0, okay, last one is 1, 0, 1, 0 in the sense 0, 1. Okay, this is the excitation table for SR flip flop. Okay, you can able to understand or not? So once again, I want to repeat that. Hello.
No, sir.
So here, what I does is what I does. They given one flip flop, and then they will ask you you want to convert it as the record format. The question is given as the given SR flip flop. You want to convert it as JK flip flop. So in order to conversion, okay, you should follow two procedure. One is called as you needed a characteristic table of record flip flop, and second one is you needed excitation table of existing flip flop. And the given question, which one is called as a existing flip flop, which one is called as a record flip flop? The record is the conversion. Okay, this one is a record, this one is a existing. Okay, first what happened? I should write the characteristics table for record one. Okay, as of now, this is called as a characteristic table, and then followed by I written as the excitation table for table of existing. Okay, this is called as a characteristic table, and this one is called as an excitation table. Excitation table. Okay. Okay. So next procedure, what we are going to do, we are going to form Boolean expression for S and R. Okay. So next thing is another. I want to form logic expression, otherwise called as a Boolean expression for S and R. Okay. First, I am taking for S. Okay. So, okay, I'm going. Okay. So, what are the parameters acting as an input in this? In J, K, and Qn. Okay, three parameters acting as input parameters. Here, three parameters are available. How many input combinations are available? So, eight input combinations. So, for that, what happen? I will take uh, three variable column. I will take three variable column. Okay, Qn and Jk. Jk 01, 00, 01, 1110. Okay. First, what happen? I'm going to generate equation for S. Equation for S. Okay. So what is the value of Q? Q is 0. Okay. And what are the places output value equal to 1? Here the output value equal to 1. Okay. The here output value equal to 1. Here output value equal to 1. Okay. And then you should consider don't care condition also. So why fill up the table? Okay. So four values are available. So Q value equal to 1 and JK value equal to 0, 0. Okay. 1, 0. Okay. So don't the conditions are available. What is the next? What is the next? 0, 1, 0, 0, 1, 0. Okay. I hope that how to fill up the table. I simply keep on proceeding on. Okay. If you fill up the table, your table should be appear like that. Okay. If you fill up the table, your table should be appear like that. Okay. And then what is the next step? You want to perform mapping. Okay. The maximum size of grouping is pairing. The maximum size of grouping is called as a pair. Okay. Further, we are not able to proceed. So now minimize the equation. What happened? Q1 JK 0 1 1 1 0. What happens, sir? This is a Q1 bar. Okay. This is a cancel J. Okay. This is the equation for S. Similarly for R. Okay. Similarly for R. Okay. Again, here three variable function. It's here. Okay. Three variables are available. So eight input combinations are available. So in order to solve this equation, we require three variable column. Check it. Okay. If you fill up the table, okay, your table should be appear like that. One, one. Okay. This is the X and the X. Okay. I hope that all of you know that how to fill up the column of table. Okay, we have seen lot of example regarding how to fill up the column up and then how to generate the Boolean expression. Okay, if you fill up like that, the table should be appear like that. So after that, what happen? You should perform mapping. Okay, so maximum size of grouping is called as a 0, 0, 0, 1, 1, 1, 1, 0. Okay, the maximum size of grouping is pair. Okay, if I'm minimizing it, what happens? Q1 JK 1, 0, 1, 1, 1. This is a cancel. Q1 K. Okay, this is the equation for R. Okay, this is the equation for R. So based on that, what happened? I generate the equation for S and R. Qn bar J. This is R equal to Qn K. Okay. K. Okay. So now what I'm going to do? I'm going to perform realization circuit diagram for or circuit diagram or otherwise called as a block diagram for this one above one for given logic function. Okay. So it's required one AND gate. This is also required one AND gate. Okay. This is okay. Okay, this is the S and this is the R. Okay, this is a Q1. This is a Q1 bar. Okay. So one of the input is J, another input K. Okay, how it's recurve Q1. It's recurve Q1. It's recurve Q1. Okay, and K recurve Q. So K recurve Q. So now what we have did is we are implementing JK flip-flop functionality using SR flip-flop. Okay. So what we have done is we are implemented JK flip-flop functionality using SR flip-flop. So do you have any queries? Do you have any queries? Hello.
No, sir.
So now I am going to take the attendance. Okay, thank you so much. If you had any queries, please stay on online, otherwise you can wind up the session.